Hello. Wait, hold on. Are we on? All right, we're on. Hello, everyone. July 8th. Um, I have 45 minutes today, so not sure if we can get it done. It's a hard one with 37% passing rate. Oof. I'll give it the best shot that we have. Substring with largest variance. The variance of a string is defined as the largest difference between the number of occurrences of any two characters present in the string. Note that the two characters may or may not be the same. Given a string S consisting of lowercase English letters only, return the largest variance possible among all substring of S. So substring, so we are trying to find the largest difference between the number of occurrences of any two characters. So in this example, AAB. So the largest will be this one, right? This the BABBB. All possible variances among the respective strings are variance 0 for variance 1, variance 2, and variance 3. So S consists of lowercase English letters, and this is 0 because anything the difference is 0. Okay. The largest variance possible among all substrings. So we find a substring, we need to know the count of every single letter that is in this, and we need to find the largest and we need to find the smallest, and the difference is the variance of the substring. Any two, yeah, but just always looking for the largest and the smallest. And it's substring, so it can be a lot of substrings, 10 to the 4th, so it can be a lot of substrings, right? So with a lot of substrings, well, and then we want to find the largest variance, which means we want a stretch with, one letter occurring the most frequent and then the other letter occurring the least frequent, right? And really have no idea just by looking at this. And we only have one solid example to kind of play with this. What do you think? Well, the substring of size 1, right? The substring of size 1 is always going to be 0 because it's the same, right? And the substring of size 2, or the substring of size 3, I mean, giving me a substring size, I'll be able to tell. Can you tell? Well, I mean, the worst case scenario, I put 2. You put 2 priority queues, one to track the max and the other to track the minimum. Or I can use sorted list. Probably not a good idea to use sorted list because you're modifying, right? Because if you think about a sliding window, if you've given me a size and I slide it through, and with each one I can find, the maximum occurrence of one letter and the minimum occurrence of the other letter. Yeah, I can find that. And then as you shift, things change, right? Things change. And as things change, you can put that into priority queue to keep track of the max and keep track of the mean. That's possible. but we only solve the variance, the largest variance of a given substring size. But we don't know which substring size, right? We don't know. We do not know. I was trying to play the idea of, binary search on this, but feels like, I don't know, how's binary search gonna work? And we're trying to find the largest. Usually finding the largest is not binary. Binary search is like the smallest, the minimum max, or the maximum min, something like that is binary search. This doesn't feel like binary search. So if we don't do binary search, I mean substring, we might be able to do DP. You think about how we can do DP. The maximum, like ending at a certain position. Hold on. If we do DP, let's say, what would a DP be? Like ending at something, the maximum, the largest variance, ending at a certain stuff. A maximum ending at this, how would that help? Like maximum ending at this is going to be, 1, 2, 2, right? 2. And we want to find the maximum ending at this now, right? Maximum ending at this, and I have maximum ending at every single one, but that doesn't help. There's a maximum ending at this helps. Okay, so ending at this, what do we want to find? So what we have, whatever the max, or whatever the max we have. Now we add a new character. Okay, we add a new character, a new letter to it. Now if the new letter we added, it contributes to the smaller, then it's actually not gonna make any major difference. Or what we're trying to say is, we add a character so we can actually see what type of change it can make, right? So look previously, and I keep count of what this one has been repeated before, because otherwise, like if this is a unique occurrence, it's something that just happened before, and if we keep track all the repeats that has happened before, right? If we keep track of that, then you can update. Yeah, let's say we have a substring. Okay, we know the total number of occurrences of each one at each position. We know that. Okay, and now this one happens. Okay, now this one happens, and we put that one in as well. So if that's a unique one, right? If the new one is a unique one that has not been seen before, then it's always going to be the maximum that we have previously minus 1, right? That's always going to be the maximum. Agreed. Okay, that's a simple case. If it's not a unique one, okay, then we have then it's a repeat, right? It's a repeat. Then we know what is the maximum before, right? We do know what is the maximum before. So in this case, A is the maximum of 4. And now B just increased. And that's actually going to bring it down, right? It's going to bring it down. So we say, no, that's not good. Okay. And now we keep going on. Now we had another B. All right. Yeah. So yeah, basically we do trying to find the maximum variance for a substring ending at a certain letter, right? For the substring ending at a certain letter. And because we want to include this. Now, if this, like I said, if it's a unique one, then we always have a solution. If it's not a unique one, it has occurred before, then if you think about it, we have, blah, 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 we have an A. Blah, 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 we have an A. Okay. So when we have this A, we know its previous occurrence, right? So within this stretch, this A is a unique one, right? It's a unique one. So we can easily find out, I'm not sure if it's easily, but we can find out the maximum variance for this, right? It's very easy. I shouldn't say very easy, but it's just the maximum occurrence of some other one minus one. That's it, right? And then we have 2 occurrences of this, right? 2 occurrences. So we can go for this entire thing because we're trying to include this. Because we're trying to find, any influence that we're gonna have by including this new letter. So you say, oh, how about we do 2 of them, right? We do 2 of them. Okay, then we do 2 of them. And it'll be the total, the maximum count of whatever minus 2, right? And the maximum minus 3, minus 4. And remember, for everyone, we'll do the same thing, right? For everyone, we can do the same thing. Yeah, so, okay, we do this. This we can do. We can record this so we know from here. So, yeah, we can know from this position, from each position to the end. Because we have 26 letters. So for each letter, we can do a prefix frequency count. So we know from certain position to certain position how many occurrences that one has, right? The frequency for every single letter. We know that. We know that. Okay, so yeah, we know what this one is, right? Now, if we have the maximum of this stretch, including this, and the maximum of these 2 together, it's not necessarily, right? It's not necessarily, because we need to know. And suppose we already know the maximum variance ending at every single position. So let's say we know the maximum variance ending at this, okay? We know the maximum variance. Will be something, right? Something. But maximum variance in this stretch might be different, right? It might be based on a different letter. Yeah, it might be based on a different letter. Can we search through the whole, you know, I mean, we have occurrences of this, right? We have occurrences of this all over the place. Okay, all over the place. And what we want to find is, including 1A, only 1A, only one of the letters. Yeah, let's say I have these occurrences of A's, right? So I want to find maximum of this, maximum of this, maximum of this, and maximum of this. We want to find all of them. So we can decide what is the maximum variance of all possible substrings ending at this position, right? So to find this, we go through 26 letters to find their occurrences in this stretch, okay? And then we wanted to find the occurrences in this stretch, and then in this stretch, and it's like every single stretch. We need to find the occurrences and to see if, if it will be a little bit bigger. But that is not a fast approach, because for each position that occurs before, we have to go through the same thing over and over again, right? We have to go through the same thing over and over again. And that's O(n) squared, which will time out. No, I don't think that's the right way to go. But this definitely feels at least tangentially is on the right path. Of 26 letters, a prefix sum of frequency, so we can find the frequency given a range. Given a range, we can constant time find the frequency of all the letters. That I can do, right? That I can do. What I need more is, and of course, right? Of course, if it's consecutive, then we can just keep skipping, but it doesn't feel right. At least it doesn't feel right. And I'm not using the fact that we have computed some of these in the past. I'm not using that, which is disconcerting. I want to use it, okay? I want to use it, but I'm not using it. I have something computed already. At each position, right? At each position, what's the maximum? At each position, what is the... So I'm going through DP, and I think maybe a way to do DP is index, and the other state is a letter, because the length of S is 10 to the 4th. 10 to the 4th times 26 seems to be a right complexity. So I'm thinking maybe something like a DP, index and a letter. Well, what does this letter mean? I'm saying, okay, ending at this position, what is the largest variance when the other letter, right, is this? Okay, let's say I know that. Okay, so at this position, so I'm looking at here, right? So at this position, I know using this, ending at this, what is the other letter? And I can have all through the other letters. What do you want to know? Like exactly. Like what type of information you need to know to get the maximum ending at the current position? Well, to know the maximum ending at the current position, which means we have to involve the current one, right? So the current one has to play a role, right? To play a role. And again, if it's unique, then that's trivial, right? If it's unique, that's trivial. But if it's not unique, right? If it's not unique, and I have the result of the previous one. Yeah, let's say we have the result of the previous one. Okay. Now in my position, it's not unique. So we go to the previous one, find out the maximum variance ending at the previous one with the same. With the same. How would that help? Let's just give it a shot, right? Let's say, we are ending at this index. I want to find the DP. I don't know, just we say the index and B. So if you want to find this, how would you do? Well, to find that, which means the other one we want B. So we can go to B, okay? Then we need to find, starting from this position, going back, right? Starting from this position, going back. The count, like how many B's has there been? Okay, let's say for B, I have a list of, index, right? I have a list of index that B has occurred before. Okay, then we need to find out, find out in like from the closest, let's say from the closest to I, right, in this range. I know I have one B. So I need to know how many A's do we have. Because that's how we calculate. And then we go to the next one. We need to find how many A's we have. We go to the next one. We have to find how many A's we have. How is this helping? Right? How can we make this like compute faster? Well, maybe we can find a B here. Find the most recent B. And everything else inside is not B. Okay? Everything inside is not B. So when I have the B here, and we have this position with, you know, like say JK, we have JKA, which means ending at this B, which is the last B, what is the maximum of substring relative to A? Right? What is the maximum relative to A? Okay, so this will tell me a value. You know, we may have some B's and we have a 1A, and then we say, okay, that gives us the maximum. Okay, and then now I had another A. Okay, then we're looking for this B. Right, we look for this B. We have this A, and we're looking for this B. And this one already tells me, oh, we go for a previous A. Go for previous A would tell me ending at that A with all the previous B. Okay, what is the maximum? It could be dominant by A. If it's dominant by A and we can count the number of B's in between these two A's. Okay, the easier case, if it's dominant by B, okay? So we have a lot of B, so we have only one previous A. And then we have a maximum of this A, ending at this A relative to B. We have lots of B, and we only have one A. That's fine. That's fine. If that's the case, then I have a new A, right? Then relative to B, if there's no B in between, or there's B in between, it's just going to be adding the number of B's in between. Either I include the previous one, so it will be the total B's minus 2, or I do my thing. That is one thought, okay? That can give me the maximum ending at this A relative to B. Okay, so what if A is dominant and B is not? If A is dominant and we have the previous one would tell me, you know, we have that many A's, we have, and relative to B is going to be some value, right? Okay, it doesn't matter. We have a stretch of A, and then we do this. Now we have another A, right? We have another A. We have another A. If we want A to be dominant, okay, then if we want A to continue to dominate, because I'm adding a new A, right? I'm adding a new A, so I'm extending, right? I'm extending. Yeah, so previous I have so many A's and I have some B's, right? I have some b's. And, you know, and we want A to be dominant. So we want A to be dominant. That's fine. And now I get my current A. So I'm ending at this A, and we want A to be dominant, right? So what, relative to B, what is the maximum variance? Now the maximum variance will be the previous, we already have, ending at the previous one, and the current. Well, add 1, for sure, right? Because by adding 1, we're increasing the amount of A's. And we have to minus whatever B's will be included there. So I think what you're telling me is, we will find dp index and some some previous letter, right? So okay, I'm adding A, right? So I want to find, let's say this is I want to find dp I. You don't have to find dpi because dpi is just 0. So I want to find dpi, b, c, d, to z. I want to find all of them, right? Which is the maximum largest variance for all of them. And this is going to give me 2 values, okay? It's going to be a 2 value. One is if I is dominant, right? If I is dominant, or the letter is dominant, right? What does that mean is if this is dominant, so this will be more frequent, or this will be more frequent, okay? So now what we're gonna do is if this, what we find is unique, never occurred before. So this is just gonna be the maximum of what we have so far, minus this, right? We can just go through that, which will be easy. We just go through every single one, find the maximum. No, don't even just go through every single one. That's your answer. And if it's unique, then when this is dominant, then it's just 0, right? Because this can include every single one that exists, will just be 0. For what if the one that do not exist? The ones do not exist. The ones do not exist. Ending at this, we want relative to something else, or we want the largest. So if it's dominant, that's just gonna be 1, right? It does not exist before 1. I think it should be 0 if it does not exist. Because we're going to use the previous, right? We're going to use the previous. If it does exist, if we have, hold on. So if it's unique, if it's unique, and we go through all this, then we'll have a dominant, and if this is a dominant, and if B does exist, then it'll be 0. If it's dominant and this previous thing does not exist, if it does not exist, well, we'll probably just go minus infinity. Okay, we just go minus infinity. Okay, so if the other become, then it's also minus infinity. Otherwise, just others minus 1, right? Because we want to find a maximum. But if it does not exist, it's just going to be minus infinity, okay? So now if it does exist, we have some a previously. So we will know if it exists, then we will go to that one, okay? So that one will give us a list, right, against B, C, D, da, 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 da. And that one will tell us also a dominant, right? A I dominant, the index dominant, and the letter dominant. We have two values. So for here, index dominant, when this is dominant, okay, then I want to know if this is dominant. Yes, I should record as 1, right? I should record as 1. If this is dominant. Okay, so now I have another one. So I can plus 1 minus whatever the frequency inside this, right? Minus whatever frequency is inside this. So we'll get the new 1 if we include both. Or we just do it by itself. I don't include this. I just do within this. Yeah, if I have a lot of occurrences of the other letter, then include the previous might actually be a bad choice. So I just do here, which will just be, if this is dominant, and if it does it exist, if it does not exist, it will be 1, actually. If it does exist, it will be 0. Okay. So what if this is the other letter is dominant? Well, the other letter is dominant, but it does not exist. So it shouldn't be minus 1. That actually is minus 1. Because the other letter is 0. Occurrence is 0. And we will also, add 1, but plus, right? Plus the diff. Yes, that'll be minus 1. And we plus the diff, and then this might actually be right. This might actually be right. Let's try it. Basically, I can build this. Hold on. Let's see if we can solve this. It's a complicated system. There are a few things I need to build, a few data structure I need. So to begin with, I need a DP. Okay, I need a DP. Can I build this DP with Can I build this DP with ALR cache? Is it possible to build this with cache? I don't like the idea of building with cache. I think I'm gonna go from scratch. So in that case, I'm going to do DP is just going to be a what's this DP gonna be? We can do a dictionary, honestly. We can do a dictionary if you want it to be a dictionary, or we can do an array. Maybe we can do an array. Let's do an array. Okay, let's do an array. But what is the content of the array? Content of the array is 2 values. Okay, so I need n equal to len s. Okay, so it's gonna be index will be a row. Okay, so for this in range n, right? That's the total number of rows. And columns, right? Columns. How many columns for this in range? 26 columns. And for every single time, every single thing is going to be 2 values. A 0 and a 0. We can just put 0 and a 0 for now. So that's our DP table, right? DP table. Okay, so what we can say is dp I j equal to I dominant. J is actually jth letter dominant. So I'm going to say S I dominant, jth letter dominant. Because max variance when this dominant or this dominant in a substring ending at si. Okay, so that's that. We also need the previous, right? We need the previous, the latest, the previous index, because that's what we are looking for. So the previous, so the pre-index shall equal to -1 times 26 for each letter. Okay, -1 means it has not occurred before. All right. What's next? I also need to know the prefix sum of the frequencies of each letter, okay, at every single position. So I know from this to this, what is the, how many, right? How many do we have in this range for every single letter? So I need a pre-index p sum of frequency. Okay, that is going to be a for this in range 26. That's going to be a 26 row, which represents every single letter, and this is just going to be this. Yeah, because I'm going to grow it. Okay, I'm going to grow it. It doesn't really matter. I'm just going to grow it. Okay, so that's the frequency. I have that done. Now what? Well, I mean, I probably should set this to 0. Okay, so this is record the prefix sum of frequency of each letter. So this is the index of the previous occurrence of each letter. -1 means the letter has not occurred before. Okay, let's try. For I in range S. Okay. So maybe we can say I A in enumerate S. Okay, so I have the current letter, I have the index. Okay, so what are you going to do? Well, what I'm going to do is, well, we're going to update a few things, right? We need to, well, we'll do some stuff, and then I'll update the prefix. So I say pre-index ord a minus, is that lowercase, should be 97. Okay, so 97 minus 97. This one will equal to I to record the update the prefix. So I can do that. And then I have to update all the prefix, right? I just say for j in range 26, p some frequency of j shall dot append, okay, append p some frequency j minus 1 plus something. This something is int char j plus 97 is equal to, you know what, it might be easier to also get, so we have I, right? So we need to have an index. So the char index equal to ord a minus 97. So now I can use char index. I'll call it CI, char index, character index. So here I can just say j equal to CI. So these are the updates. So these are the updating the states of pre-index and pre-sum frequency, p-sum frequency. Okay. So now we are doing the meaty part, right? The meaty part. So the meaty part is to find out ending at CI, right? So we have to go again, right? For j in range 26. For every previous j, right? And I need to ask if pre-index CI is equal to -1. Okay, so this means the current letter has not shown up before, right? Now, if that is the case, then we say this is an easy case. So we'll just do this easy case. And how do we do the easy case? What we want to fill is dp, dp I j, right? dpij. So dpij shall equal to something, because I am unique, right? So what I want to find out, is for me, so the first is I is dominant. Okay, I is dominant. So which means I'm dominant, so I'm gonna be 1. Okay, because it never happened before, so it's just me minus something, the count of j so far. And how do we find the count of j so far? We go to p-sum frequency, right? P-sum frequency of j, and the frequency so far, so far, not including the current one. So that's going to be just a -1, right? That's so far. And of course, we need to find a maximum of this and 0. If it has not occurred before, then that's going to be a 1, because this is going to be 0, right? It has not occurred. If it has occurred, if it's 1 occurred, that's going to be otherwise more than 1. So I need a maximum of this. So that is SI dominant. Now I need the jth letter to be dominant. Okay, so the jth letter to be dominant. For this jth letter to be dominant, okay, for the jth letter to be dominant, I need this jth letter to be dominant. I need to find the current count of jth letters so far, right? And this one -1. Because the jth letter is a dominant, which we just find the total number of the jth letter, right? And that -1. Okay, so that's the case when this letter has not shown up before. Else, this letter has shown up before. Okay, it has shown up before. Then we have a pre-CI. It's going to be pre-index CI. No, it's not pre-CI. Pre-I. Pre-index. So pre-index, this pre-I is corresponding to I. So that's the pre-index. Okay. Now we need to find out exactly the same thing, right? We need to find out dpij. Okay. So we need to do dpij, the same thing, equals something. All right, so now we want to find out if SI is dominant. Okay, if SI is dominant, I find the previous occurrence is dominant, right? So we find the previous that's dominant. How do we find the previous that's dominant? Well, we'll find by dp pre-I. I call it pi. How about that? We call it pi. Okay, we call it pij 0. That's the previous occurrence of the letter when it is dominant. So we get whatever it is. So that gonna plus 1 minus the something, and that something is going to be the total frequency of the letter, of the jth letter in between the I and the pi, right? In between I and the pi. How do I find that? Well, we use p some frequency j something minus p some frequency j something. That is how we find it. And what is this first question mark? Well, that is going to be -1 because we're going to the end, right? We're going to the end. There's a total occurrence. What is this? Right? What is this? This shall be pi, right? Because the total occurrence up to pi, because we want it after pi, right? After pi to this, so it should be -1 minus pi, okay? Minus pi, but it's 1 based, okay? It's 1 based. So we need to minus, not pi, I think it should be pi plus 1. Oh God. My head is about to explode. Yes, pi plus 1. Pi plus 1, you will get the frequency of the jth letter. So that's that. Okay? That's that. That's one scenario. That's one scenario. And we want to find the maximum of this scenario and something else. There's another scenario. Another scenario is I do not include PI. I do not include the previous occurrence of the same letter. I just don't include it. Okay? If I don't include, I only have a stretch. And it's actually exactly the same as this. So I'm going to copy and paste this with a small change. That's not going to be 1 minus the whole thing. It's going to be 1 minus this thing. Because I want to know the frequency in the stretch between the current letter and its previous occurrence. Right? In this stretch, within this stretch, the current letter is unique. So it has one appearance minus whatever the jth letter, the number of jth letter occurred in this stretch, right? 1 minus that. And if we have too many of this, and then we're just gonna do a 0. If it does not exist, we'll do 1. So that's first. That's the SI dominant. And there's another one is jth letters dominant, okay? So for jth letters dominant, we're just gonna give max again, right? Again, so the first is gonna be dppi j1. This is the jth letters dominant. If jth letters dominant, okay, and if I want to include that, then we say we need to be the previous, right, plus total number and minus 1. Right? Jth letter is dominant. We will add the total number of the jth letter in the stretch. And because we include this, so we minus 1 again. So that's that. Or we don't do that. Then what we do is what do we do? In this case, it's going to be the same. They're going to be this amount, right? This amount minus 1. Think about it, right? That it makes sense because you're in the stretch where we do not include the previous occurrence. Now within the current stretch, the current letter is unique, right? So we need to find out the total number of occurrences of the jth letter in this. And if we don't have, then just minus 1. Yeah, unfortunately it's going to be minus 1. If it does have, it's just going to be that minus 1. So we go through this. We acquired dpij, right? Now we need to have the result. And the result will say res will equal to maximum res and dpij. And after that, we update these and then we'll return res. All right, let's see if it's right. Oh. A, B, A, B, 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 A, B, A, B, 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 that should be 3. A, B, C, D, E, that should be 0. Oh, I'm very nervous. This, I might be right, I might be wrong. It is not right, but it's close. It is close. I guess maybe we got a little bit mistake somewhere. Where do you think we have the mistake? Jeez, man. Some signs or this will be easier to debug. Let's debug this one and see what we can do. How you want to debug this? Well, what we can do is probably after everything, I want to see, let's see for row in DP, print DP, okay? And we'll print pre-index. We also print psum frequency for row in psum frequency. We'll print row. Oh my god, oh my god, oh my god, oh my god. How is that helping? That's not helping, man. That is not helping. Well, I think the problem is this 1 minus. If the thing does not exist, I think it should not be 1. That's troubling us. If that does not exist, I think -1 is okay. But this, if it does not exist, I'm saying it's 1. But it's not 1. Then what value should I put it? What value? Yeah, this is useless. This is useless. What value should I put it if this does not exist? Yeah, you're looking at a current thing, right? And you're saying, I'm at ith position. I want a jth letter, right? And the jth letter doesn't exist yet, right? It does not exist. So I say if my is gonna be dominant, okay, and previous doesn't exist, and if you do this +1, and your minus something does not exist. But then if it does happen, it does exist, that is going to be bonkers, right? What if in the future this is not 0? This turns out it does have a value. So what, do you have to put like a asterisk mark on it? Like it's not real? Like it's not real? That's ridiculous. It's not real? Is that what you're trying to say? It's not real? Yeah, I think this is exactly what you're trying to say. You want to say that it's not real. Yeah. In a market as not real. Holy crap. How do we mark it as not real? Oh, God. We need to mark it as not real. But once it becomes real, jeez. So we have a value, right? But it's not real. It's just a total count, right? It's just a total count. It is the total count, right? It's the total count of the current value at this position, and it's not real, or it can be real. It does become real if this is larger than 0, right? If this is larger than 0, or this is larger than 0, then it becomes real, right? It becomes real. So I guess we just, yeah, that's basically it, right? That's basically it. If it's, but it also depends on whether this value itself is real or not, right? So we can just, oh my God. And here, oh, I absolutely detest all of this. Detest. It's just so complicated. But for one thing, let's make this into a tuple. So we have a little bit less. So we have two things, 0 and false. Okay. So we're gonna have this, and this is gonna be real or not, right? Real or not. So for every single thing, let's break it down. Let's break it down. Dear me. All right. So here is going to be a thing. We're gonna do this. Okay. And 1 minus, because this is unique, okay? 1 minus this, and this is gonna be, is this larger than 0? Is this larger than 0? If it's larger than 0, then it's real, right? That's true. If it's not, that's false. This is a false. So we have to do this. And the other possibility is, so that is that. And here is going to be different. Okay, this is going to be different. So in the first part, okay, in the first part, and in the second part, oh my God, oh my God. It changes everything. Because it depends on whether this, right? If this is 0, which will make this depend. If this one is real, then it continues to be real. If this one is not real, then the whole thing is not real. And oh yeah, if this one's not real, then we'll continue doing unreal. And for this part is, yeah, what if this is unreal and this is real? We'll pick the real one. Okay, so if this is, oh my God, this doesn't affect. I think it's only this. Okay, so what we're gonna do is we will handle the first one separately. We'll handle this one separately. So we just say this. Okay, then we'll handle it separately. How do we handle it? How do we handle it? We say if if dp if this is real, right? So the previous one's already real, then we just, it's +1, minus is fine. And so the previous one is real. What if the previous one is real, but this become unreal? So we don't have anything here. If we don't have anything here, then we definitely go with the previous one. Whatever the previous one is, we'll get a better deal. Yeah, we'll get a better deal. Whatever it is. No, we don't really get a better deal. We don't. We can maintain an unreal, right? Oh God. No, that's not the way. That's not the way. This real, unreal talk is just ridiculous. It's ridiculous. No, it's just ridiculous. I feel I'm like so close, right? I'm very close to get it, but this real, unreal talk is just ridiculous. Because, so we need to have like, what if it's real? What's gonna be? What is unreal? It's gonna be. So we had to keep two separate. One is if it's real, and the other is if it's not real. That I can get behind. That I can get behind. So we're gonna have two things. So we do have two. So it'll be 0 and 0, right? So this is dominant when real. When feasible. And the other is SI dominant when not feasible. So in this case, God. All right, we'll always do this. Then we say, you know, if this is larger than 0, then it will be real, right? Then we have real and unreal. When we check, it will always check for real, right? We'll always check for real. So we say if this is larger than 0, then dpij 0 or equal to this. Alright, if it's larger than 0, then it's just gonna be 0. Right, it's just gonna be 0, 0. It's not gonna be unreal. There's no unreal because we have. Okay, so we can say minus math.inf. There's no possibility of unreal. It's feasible. Right, it's feasible. It exists. Now else, if it's else, then this is going to be 1. But it's unreal, it's unfeasible, right? It's unfeasible. But if you ask me what is feasible, feasible currently is this. Okay? So now we come to this, right? Now it's the same question. We're gonna say the count. Right, count j will equal to this. So we get the count out. If count j is larger than 0, so it can be real. No, it should be, right? It should be real. If count j is larger than 0, what do we have? Well, if count j is larger than 0, and we have a dominant, right? We want I to be dominant. So we look for the previous, right? We look for the previous. Okay. And the previous shall have, oh no, 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 no. No, that doesn't feel right. It does not feel right. I think I'm doing too complicated on this. You know what? I will pause for now. I think we have to do a part 1, part 2 because I need to do something else right now. So I'll stop here and go back to it. Just give my brain a little bit of rest. I feel like I don't have to do the 2 scenarios. I think I just need to do 1 scenario. Seriously, I just need to do 1 scenario. That's what I think. I just need to do 1 scenario, which is but if you just do 1 scenario, because this one is easier, right? The jth dominant is easier. So go through every single one. You say j is the dominant one. But I can say b is the dominant one. Right? B is the dominant one. All right, I'll stop right now. I'll be back later. I'll be back.